Okay, this is an example problem for Physics 1000, Auburn University, summer 2013. In a previous video we calculated equivalent resistance of this series circuit, so I'm going to ask a new question this time, which is simply, what is the current flowing in this circuit? We've got everything we need to know to answer this question, but it's important to remember from class what governs circuits like this, what governs our calculations, is good old Ohm's law. The voltage, or the potential difference in a circuit, equals the current times the resistance of the circuit. So we're looking for current in this case, so let's go ahead and rearrange this equation and solve it for current. I is going to equal V over R. This is my favorite form of Ohm's law. We always remember it using this form because it's easier to remember V equals IR than something involving fractions. But I actually prefer this version of Ohm's law because to me it tells you a little bit more about the physics. Because typically what we're interested in is the current. Not always, but typically. And this tells you exactly how current works. It is directly proportional to the potential difference, or the voltage, and it's inversely proportional to the resistance, which makes a lot of sense. If you're trying to send a current through something and that thing is resisting you, you would expect to find less current the more resistance it gives you, and if it gives you less resistance, you should expect to find more current. Similarly, if we're using, like our classroom examples, voltage being sort of the pressure for the flow of current, that's an analogy from mechanics, you would expect to find a greater pressure is going to equal a greater current. Or if you're thinking about a hose, if you put more pressure on the water in that hose, it's going to flow more, and that makes perfect sense. So I like this form of Ohm's law because it shows me exactly what's going on. But this is what we'll need to find the current. And in this case, the first thing I need to do is simplify this circuit to a form where I can manage it. We've already done that in the video by finding the equivalent resistance. If that's sort of Greek to you, you should go back and watch that video. But I'm going to redraw this circuit like this, where I've simplified it. I've taken R1 and R2, and I've found that they have an equivalent resistance of 25 ohms. Again, if that really confuses you, you don't understand at all what I did there, go back and watch the video on equivalent resistance in a series circuit, and it should make some sort of sense. But now I've got the circuit in a form where it's very, very easy for me to find the current. At this point, I just plug in the numbers. I've got current is equal to V over R, which in this case is 9 volts, over my R, which in this case is 25 ohms. And volts over ohms is an ampere, which is the unit of current, which is just 9 over 25 amps. Of course, I could plug that into a calculator and come up with a decimal point if I wanted to, and that's fine if you want to do that for your answers. But I usually prefer to leave everything fractional just because it's more accurate. So that's it. It's just sort of one step. But the crucial thing is to recognize here that you've got to do this step. You've got to find the total resistance in the circuit that this voltage source is trying to push against to find out how much it's able to push against. So if you just did this with just using R1 or R2, you're going to come up with the wrong answer, because in fact, from the perspective of the battery, this situation, let me get a different color. If you're the battery, this is really what you see. You don't really care that there are two resistors, R1 and R2. You feel that there's 25 ohms of resistance against you. In the actual circuit, you might find two resistors that make up that, but if you're the battery, all you feel is 25 ohms of resistance. So what the current you're able to push through that circuit is equal to whatever that current is for this one 25 ohm case right here. So hopefully that makes some sort of sense. If not, please email me or come talk to me. So that's the equivalent, that's the current flowing through this circuit, which we've calculated using the rules for series circuits. Not that big a deal. I'll see y'all next time.